everybody. Welcome back to non-body work on Audis. I just saw the previous segment with the R5. That's one thing I had to do, and that was a really major thing, and I'm pretty proud of it. And now I have to do this. There are certain things in these cars that really suck, and one of them is the shifting mechanism. Now, anybody who knows who's driven them all know that the shifting mechanism is like, it's not that great, What did they? Most of the reports at the time said it was a rubbery shifter. And I'll agree. It wasn't very positive. It didn't really click very well, and it just wasn't a good shifter. As in, how can I put this? Driver feel. As in taking out vibration from the gearbox to the shift knob, yes, it was awesome. Because there was so much dampening in between the actual shifter and the actual transmission, it really, get rid of all the vibration. But we're not into that right now. We want something that actually feels good or has nice, positive shifting force. But what we got to do, in order to replace the front part of the shifter, we have to go to the back of the transmission first, because we have to do this in steps in order for me to do this out of the car and not in the car. All right, so let's go to the back of the transmission. Let me show you what I'm planning on doing. This right here is neutral on my input selector shaft. Here is the shift rod, the shifter, and the bushing that goes on it. Right here is how Audi did it. They had two, kind of like a hard rubber maybe. I'm not sure exactly what they are, but what is just, I would say, rubber bushings inside here that pop onto this ball. These things, right now, after 40 years, they're petrified. They're fossilized. That's how hard they are. So, what are we going to do? Well, the first things first, I'm not going to push this thing on, because I'll probably never get it back off without breaking something. But this right here is the exact position of where the shifter is in relation to the car, right there. So what I want to do is I want to build a jig off the back of the transmission to keep this shifter assembly in, it'll be in neutral, exactly where it is. So once that is there, I know I can cut this off and start redoing everything right here without knowing, I know exactly where everything is going to be. That's the big thing. So let me get my gear on. Well, actually, let me first pull off the back portion of this rubber bumper right here, and let's start making a jig for the shifter assembly to sit and bolt onto, and so it won't move. here's the mount that we have. Is it good looking? No. What is it? Cheap, free, and stable. Not quite free because you had to use well or whatever, but it's all just junk crap that I threw on here. What it is, I found these pieces in the trash bin. That's all it is. Like the bottom piece down here from an old garage door. This is from an old header flange, our turbo flange. This is just a piece of metal I have there and I cleaned up, you know. The only thing is that it is now stationary. The shifter's in the exact position where I want it, and you're probably looking at this right here and you say, well, geez, if it's in the exact position you want, but this thing's at an angle, why is that? Well, let's take a look. Looking at the shifter right here, you can see this is angled down in the neutral position on the actual shifter itself. Why is that? It's because this is angled down. When this is angled down, this is angled down right here. If this is in the center, that means I have the utmost of left to right ball action that I can, you know, that's floating on this rotation or into these bushings. The big thing is you gotta have, if you had it straight like that, that's not the correct position because this is angled down. It has to be angled like that to meet this plane right here. So that's the reason why it looks like that with the position in the neutral position right there. All right, let me explain to you the shifters I have. Here's the jig all set up. You know, doesn't look great, but man, it works. Because if you move this, it doesn't move. The whole transmission moves back and forth, so it's pretty stable. Now, we're trying to replicate some motion here, or the motion of this shifter right here. Now, what we need to do is we need to have a shifter that, if I hold this, I'm not going to put it on it, but goes back and goes forward. Okay, there's no binding. We also, this is the adjuster that goes on the transmission and on the shift linkage. One goes on the transmission, the other one goes on the shift linkage to hold it steady, because when you turn this, it's turning that twisting motion into linear motion. So it's basically pushing out or pushing in the shift rod. So that is what we need to replicate without binding, for one thing. That's the problem that I had with the time joint. It bound up on the extremes. And what we have to do is have an adjusting rod that we know that we can buy. And you see these adjusting rods? They're plastic. When they get super brittle and break all apart, they become steel that you can't use. So there you go. All right, let me let's come over to the bench. Let me show you what I got to do all of the shift or to replace this shifting mechanism right here with parts that's readily available. Come on over. Here at the bench, we have a whole bunch of parts and pieces. What are we going to do? Well, first things first. This is the selector rod from the 5000 Quattro that I use for the drivetrain for the Sport. This is to show you what happens to the material that's inside that surrounds that uniball that goes into the transmission on the shift linkage. As you can see right there, there's nothing in there because it deteriorated and grumbled out. That's the reason, you know, and it seems to be a big problem with lots of these cars now. Now, what I did initially was this. I welded in a point where I could put a Heim joint in it. And what it was, I put that in so there'd be no slop in the actual shift linkage. Well, the whole thing is, as you can see right there, that would be, let's just say that's first, that's second. But if I adjusted this to where first had a good engagement, it would only go back to just where it barely engages second and it wouldn't do anything else. So I don't have enough deflection to do this. Now, when you move it from side to side, you know, to go from the range of first to second, third to fourth, fifth to reverse, you know, in that section right there, I have plenty of room, no problem. But it was the back and forth movement that really limited me. So what am I going to do? Well, I have a ton of these things sitting in a box. You know, I take them off everyone. I never knew what I was going to use them for. But these are steering U-joints. Any car, all cars have them. The steering column comes down, connects to this, and it goes down to the steering, either steering rack or steering box. And you have plenty of movement back and forth either side. And I was sitting there looking at it going, huh. So I decided to say, well, most people don't have these steering joints kicking around. I said, well, I wonder how much they are. Well, you can find universal ones really cheap. You know, I was looking on like eBay for like 20 bucks, you know. And I'm sitting there going, oh, well, this might, if this works, this will actually be a good solution to this, you know, deterioration problem. And actually, we should get a much better shifter, because when you move this, there's no play. So when you put it in, you know there's no play going in. You still have the problem of the plastic assembly on the bottom of the shifter, but that's beside the point. What this does is it cleans up all the slop of what was in here and the deterioration and so forth. We're going to try to fit this to that. Now, you're probably wondering, this adjuster right here, where it fits onto here and down to the transmission, well, what are we going to use for that? And this is what the adjuster is, stock, and it's just plastic and rubber and stuff like that. And this also deteriorates, like I showed you before, that it just deteriorates and just falls apart. All right, well, what are we going to replace this with is this. All it is a hind joint adjusting rod. I think I bought this. This is off of a motorcycle something. I mean, I'm not sure, but all it is I have two M6 spherical bearings with an adjuster in the center, and it goes out, goes in, and you can adjust where the shifting points are. So, and when you have this thing all locked up, there's no play in it, so you have a really good shift action. Now, you're probably wondering, how did I come up with this idea of using the U-joints for the steering, or for the shift linkage? Well, when you take apart a lot of cars, this is what you get. This right here, this is a shift assembly from a B5 Audi. And I always wondered why the shifter was so much better in the Audi B5s, you know, and then the 4000s, and also the 5000s were actually much better. And usually it's this right here. It's the stabilizer rod that bolts onto the transmission. But if you take a look, they have a U-joint right there for the A4. Now, the shift rod, it's internally in the transmission, is different. The one on the A4 is straight in. I wish they did it on this one, but you know, ours is 90 degrees, so we're hopefully, you know, that 90-degree transition with the U-joint will actually work. I'm not sure, but hopefully it will. Also, you're probably thinking, is that a new idea? Well, if you take a look at this, this is another German car, and they used half a U-joint right here. And you can see this thing is completely deteriorating. But what this is off of is a 914 from 1970. So you're sitting there looking at it going, well, they used like half a U-joint here, and there's another combobulation that goes into the transmission, you know, on the 914, because that also is sideways for the shifter select rod. But we're not going to do it the way the 914, because the 914 is really not the greatest shifter in the world. But all right, let's go over to the gearbox and let's take off that original ball and center section, and that way we can start cutting it up and see if we can make these U-joints fit. Here's the assembly we're going to be replacing. It fits on this rod. We know if we only go to right here, this thing will definitely be able to go in and out, but we're going to test everything anyway. What we have here, this is a smooth bore to a smooth bore on this shaft right here. Now, the thing is, you're probably wondering, if it doesn't have splines, how can it stay in one position? And it's this. This is just, basically there's a cone on the end of this bolt. It goes inside. And it has another cone shaped on the other side of this shaft right here, and it just locks itself in. And that's all it does. Because there's really not much force on this thing. Now, what am I going to use to replace it with? Well, first thing is, we need to get the diameter of this shaft. Well, I went through my box of junk, and I found this. What is this? This is off of an engine stand. And there was a ridge on the tubing inside here. It took me 2 seconds. I used a file it down like that just to make it smooth with the rest of it. And I went like that and going, no movement. It fits perfectly. It's like, oh my God, this is awesome. So what do I have to do? You can see the distance from here to here is where this was. And this is as far in as I can go. This is max. So what I'm going to do is, first things first, I am going to cut this out to where it will fit max over here. And then I am going to drill a hole. Use this. This is from a seat belt, like a Mark III adjustment belt or A4 adjustment for a seat belt on the B pillar, because it has really strong threads right here. Weld, and it's round, and I can cut this off and I can weld it onto this. That way I have this bolt right here, or this bolt. They're both pretty much the same. One's longer. This is Torx. I probably won't use this. I'll probably use this, which is a 13 millimeter head. They're both conical bolts like that. Though they pretty much fit right in there. A little bit of play in there. I might have to take it down with a file. I don't know, but let's see how it works first, and then we can always go from there. That's it. This is all experiment. So first things first, what I'm going to do is I am going to trim this out, and I am going to cut a hole, and then we're going to start putting the U-joint on, or trying to figure out where the U-joint's going to go. This is proof of concept, and I like it. Okay, imagine my arm right here is that hind jointed adjusting arm, and I lock it right here. Well, it goes in for a second, and then it goes in. I mean, it's just, you know what? I think it's going to be cool. Well, what I majorly got to do is I got to start trimming this thing down. This will never fit in the car. This will never fit in the car. I got to lower it right down. But it gives me a starting point. So what I'm going to do now is I'm going to take this back off. I have to just slice everything as much as I can, lowering it down as far as I can to the gearbox. Then I'm going to make a plate over here, make the adjuster, and I think we're good. The worst part about this is the actual shifter, that plastic ball in the shifter. I got a solution for that at the end of the video if I have enough time. But I am actually really liking this. I am really liking this. Proof of concept. Now I gotta trim it up and make it work. All right, let me go grab the my other stuff on, and then we are gonna. I gotta just take this off, and I gotta start cutting everything down. That's basically it. So, pretty happy about this. All right, let's, yeah, let me go do that. Well, that is reverse. This is reverse. So I think I have the distance set. What I did when I welded this, it's taken me a little while because I welded it, stop, welded it, stop. And what that does is make sure there's not too much heat into the U-joint so the grease doesn't boil out. That's why. As you saw me cut the bolt, that's my adjuster. And basically what I'm doing is it's not gonna be a mechanical adjuster, it's adjusted to where I think it's gonna be, and I'm welding it. So, and now we gotta now that we have this, I've got it down as far as I can, and now we're going to set the adjuster right here after I weld this. I'm just gonna give one good tack on this, just if I have to change it, I have to change it. Oh, we are done. And we have two built. The one for the rally car and the one for the Sport Quattro. I wanted to show you a couple things that I did, and tell you what I did for parts on these. This is stock. This was the U-joint for the steering assembly. This little thing right here to hold the M6 for the adjuster, just a piece of this. And you're probably saying, what is that? Well, it's the hold down plate or hold down bar for the cam cover on the 10 valves. But the one I used on here was for an 8 valve Volkswagen, because I'm never going to build one of those shit boxes again. So I used that one. I'm more apt to build a 10 valve than I am an 8 valve Volkswagen. So that's the reason why I chopped that one up. But other than that, I mean, we have the little piece right here that slides onto the input shaft, or steering selector rod from an old engine stand. And I just trimmed it out. The side thing for the seat belts from Mark III gave us the nut certs, just some standard bolts. What else? Nothing really else. I mean, just this little adjuster right here. It works really, really well. Oh, what I put onto the gearbox is all it was an M8 stud with a nut. That's it. And I ran it down, rough measurement, put an M6 cap head on it and welded it on. That's it. You could pull it right out and put the original right back on if you wanted to do it. I don't know why, but this is, it really is stiff, And everything about this, just the feel from here to there is so much better. So much better. I mean, than the originals. I am like so impressed, that this actually worked. So you remember, you can use any steering knuckle. If this is a Toyota and this is a Mark III Volkswagen, you can use anything. Trust me. So other than that, thanks again for showing up. I really appreciate it. I hope this helps someone out. Because I know parts are getting scarce, and we gotta hillbilly it somehow. So, but other than that, I mean, remember, you can do any of this. It's not hard. The only fancy thing I had was a welder, but you can buy a Harbor Freight cheapo if you really, really want to, a flux core, and do the same exact thing. I'm nothing special. So I'm just a hillbilly out here in New Hampshire, and I hope you can do this too. So, all right. Well, thanks again. Oh, I almost forgot. The bolt that I cut up to slide right in here, and it slides in perfect. was a head bolt from a 20 valve Quattro, 3B. They're stretch bolts. You can't use them again. I went to studs on all my motors anyway, but I just keep these around just in case I need something, you know, to weld on. And boy, it worked slick. It works so nice. It goes right in there. So, but other than that, thanks again for showing up. I really appreciate it. You know, I don't know what the next one's going to be. I have an idea. It might be kind of cool, but it's going to be on the rally motor. All right. But other than that, thanks again. And I hope to see you now. So hope to see you soon. All right. Bye now. All right, this is an addendum to the end of the video because I didn't have these parts. I went on eBay, and because seeing how I got an M6 adjuster and we have to fill an M8 hole, I said, well, I wonder if they have any like M8 to M6 studs. I know they have M10 to M8, but I didn't know if they have M8 to M6, and they do. So I bought a package, and they came in after I'd finished the video. So this is just, you know, and then the next addendum. But what it is, check this out. See how they are, the M8 to M6? And if I take this adjuster and put it right here, take a look at the amount of travel this thing has. And I'm sitting there going, huh, this is really interesting. And what I got was a 20 millimeters here and 20 millimeters here. So it's a 40 millimeter stud total length. Now let me pull this out right here. This is the stud that I actually made. And what it is, here's the stud that I made, which is, you know, whatever, threw it together with junk parts. But what I did was I measured how much thread depth is inside here. This is a good thing to have. When you throw away your wipers or replace your wipers, on the sides of the wipers, there is some, how can I put it? It appears to be stainless steel, but these things work great. They're the support ribs for the rubber. And I save every single one of these. Why? Because you can bend them like this, go in here, pull it up to where it's exactly where it is at the base or the depth of the thread. You pull it out, take your caliper and measure it. And what do I have? I have 10 millimeters of depth of thread. So when I have a 40 millimeter stud, 20 millimeters in length on M8, so I got 10 millimeters of a topping, if you want to call it that, above the total thread count inside there. And this is what I basically made right here. Well, not made, but I found the nut. You bring it down to 10 millimeters, and you just thread it in. And make sure as soon as that nut bottoms out on the bottom, because if you keep turning that stud, it'll keep going in. Take that, hold the top of it, and just tighten it up. And I sat there, I was going, you know what? That is like super stiff. And it just saves you a little bit of time. Now, the problem that's going to be that you're going to have with this adjuster is not going to be the bottom, because you got plenty of free play on the bottom. What you're going to have is a spacer on top so the nut does not conflict with the top amount of travel. And this is what I built. Let me show you over at the bench how I built it. Here is what I built the spacer out of. The only thing this is just 5/16 fuel line, but this was just a hose bar on this broken regulator. What I did, I used this. I'm only going to take like 3 or 4 millimeters there because we don't need very much. Let me cut this off. You're going to need a small set of pliers. You got to put this in the pliers just tight enough, and don't clamp it down because it'll distort it. Here's a round file. Use it for sharpening chainsaws and small things. Just put enough tension on it. Here is the stud with just the nut on it. Take a look. There's not much free play back and forth. I mean, there's enough, but you know what? You don't want to run the risk of binding it. Now, I cut this little bushing off of that old regulator. Let me show you what. Now check out the travel. Look at that. So we're not going to have any possibility of binding. That's the thing. All right, let's go install in transmission. There's one small thing you're going to have to look out for, but it's going to be okay. Here's the adjuster, fully installed. The car's at neutral right now, or the transmission's in neutral. The closest this adjuster will come to this. This is the vent cap for the transmission. If we pull this out, like this, you can see the adjuster goes down all the way forward. Okay, that is, what was that, it's 5th gear. This adjuster cap, can you see my fingers moving it? It goes up and down. You miss it by about 1 millimeter. So this stud is good. The 40 millimeter stud, 20 millimeters M8, 20 millimeters of M6 is gonna work. It's gonna be close. So when you build this shift mechanism here, make sure this is high enough so when this thing goes in, you're gonna clear this. But if you start with this M6, because I started with that other one that I made, this I just happened to luck out with this. But it works friggin' slick. I really like it. All right, that's my little addendum. Thanks again. Remember, you can build any of this. I'm not that smart. I'm just a hillbilly out here in New Hampshire. So you can do this. Trust me. All right. Have a good one.